Hello and welcome to this video on dark energy. The discovery of dark energy is one of the most significant discoveries in modern physics and cosmology, as it has fundamentally changed our understanding of the universe. In this detailed explanation, we'll explore what dark energy is, how it was discovered, and what we currently know about it. What is dark energy? Dark energy is a theoretical form of energy that is thought to be responsible for the accelerating expansion of the universe. It is called dark because it is not visible and cannot be directly detected by telescopes or other instruments. It is believed to make up about 68% of the total energy density of the universe. To understand how dark energy works, we need to go back to the concept of the universe's expansion. In the early 20th century, astronomers discovered that the universe is expanding, which means that galaxies are moving away from each other over time. This discovery led to the development of the Big Bang theory, which proposes that the universe started as a single point and has been expanding ever since. Initially, scientists thought that the expansion of the universe was slowing down, as this is what would be expected if the universe was dominated by matter and gravity. However, in the 1990s, astronomers studying the light emitted by supernova, which are exploding stars in distant galaxies, found something completely unexpected. The expansion of the universe was actually accelerating. This led to the discovery of dark energy. The discovery of dark energy was made possible by measuring the brightness of the supernova, which provided an estimate of their distance. By comparing this distance to the redshift of the light emitted by the supernova, which is a measure of how much the universe has expanded since the light was emitted, astronomers were able to determine the rate of expansion. This discovery was a major breakthrough in cosmology, as it fundamentally changed our understanding of the universe. It forced scientists to revise their models of the universe, as the existence of dark energy was not predicted by previous theories. What does dark energy do? Dark energy is believed to be a force that is pushing galaxies apart and counteracting the gravitational pull of matter. It is thought to be a property of space itself, meaning that it exists everywhere in the universe. The reason dark energy is so difficult to detect is that it is incredibly weak. It only becomes significant on very large scales, such as the scale of the entire universe. On smaller scales, the effects of gravity and other forces are much stronger, so dark energy is overwhelmed. There are several different theories about what dark energy could be. One possibility is that it is related to the vacuum energy of space. According to quantum mechanics, empty space is not actually empty, but is filled with particles that are constantly popping into and out of existence. This could create a type of energy that would cause the universe to expand. Another possibility is that dark energy is related to the properties of fundamental particles. Some theories propose that there could be a type of particle that is responsible for dark energy, although no such particle has been detected yet. Another theory is that dark energy is a property of the fabric of spacetime itself. This idea is based on the concept of the cosmological constant, which was proposed by Albert Einstein in 1917. The cosmological constant is a value that represents the energy of empty space, and it could be responsible for the accelerating expansion of the universe. Another possibility is that dark energy is related to the so-called quintessence, a hypothetical scalar field that permeates the universe and drives its expansion. Unlike the cosmological constant, which has a fixed energy density, the energy density of quintessence can vary over time and space. This could potentially explain why dark energy has become dominant only recently in cosmic history. One of the key questions that scientists are trying to answer is whether dark energy is a constant force or whether it changes over time. If dark energy is constant, then the universe will continue to expand at an accelerating rate indefinitely. However, if dark energy is changing, then the fate of the universe could be very different. It's possible that the expansion rate could eventually slow down or even reverse, leading to a Big Crunch scenario in which the universe collapses in on itself. Another interesting aspect of dark energy is its potential relationship to the concept of multiverses. Some theories proposed that there could be an infinite number of parallel universes, each with their own unique physical laws and properties. Dark energy could potentially play a role in the existence and evolution of these parallel universes. Despite its mysterious nature, dark energy has important practical implications for astronomy and cosmology. Understanding the effects of dark energy is crucial for accurately predicting the behavior of celestial objects and for making accurate measurements of cosmic distances and velocities. One of the most exciting upcoming projects in this area is the Wide Field Infrared Survey Telescope, allowing scientists to study the effects of dark energy on cosmic structures with unprecedented accuracy. Scientists are using a variety of tools and techniques to study dark energy and its effects on the universe. One important method is the use of cosmic microwave background radiation, which is a relic of the Big Bang and provides a snapshot of the universe when it was only 380,000 years old. Another method is the study of large-scale structures in the universe, such as galaxy clusters and superclusters. By measuring the distribution and movement of these structures, scientists can gain insights into the effects of dark energy on the universe's expansion. Finally, scientists are also studying the properties of dark matter, which is a separate and equally mysterious substance that makes up about 27% of the total energy density of the universe. Understanding the relationship between dark matter and dark energy could provide important clues about the fundamental nature of the universe. In summary, dark energy is a type of energy that scientists believe is responsible for the accelerating expansion of the universe. While this concept is still largely theoretical, the evidence for its existence is compelling and has led to a major shift in our understanding of the universe. Despite decades of research, many questions about dark energy remain unanswered. For example, scientists do not yet know what dark energy is made of or how it interacts with other forms of matter and energy. However, ongoing research and upcoming projects such as the Wide Field Infrared Survey Telescope will provide more data and insights that can help us to better understand the properties of dark energy. Furthermore, the discovery of dark energy has important implications for the fate of the universe. Depending on its properties, dark energy may cause the universe to continue expanding indefinitely, or it may eventually lead to a big freeze, where the universe cools and expands until all matter is evenly distributed and no further structure can form. Alternatively, dark energy may be subject to fluctuations or other unknown properties that could result in different outcomes for the universe. In conclusion, while there is still much to learn about dark energy, it is a concept that has revolutionized our understanding of the universe and has important implications for its future. Ongoing research and technological advancements will continue to shed light on this mysterious form of energy, and we may one day have a more complete understanding of the fundamental nature of the universe.